So today we're going to be talking about circular motion. And two things we need to remember is that when it comes to circular motion, right? In today's problem, we're going to be looking at velocity, which is just distance over time. And we're going to be looking at circular acceleration, which is AC equals velocity, right? Squared over R, which R being radius, okay? And another thing to keep in mind is that when you're looking at velocity at any point in time that you're picking, it's going to cause a slope, and it's going to look something along the lines like this. So depending on where you pick it, there will be a slope. And we need to remember also that when it comes to acceleration, that acceleration wants to pull inward to the object that we're observing, inward. Okay, so now let's begin with the problem for today, which is going to be this. Okay, so it says we have to look for the orbit velocity in meters per second squared of Earth around the sun. So now we are going to have to find the velocity, it says, right? The orbital velocity. But we need to find it in meters per second. And in this problem, it gives us it in days, the time in days, and it gives us the orbit radius in meters already, thanks to us. Now we have to look at, to convert the days for Earth, which is a full rotation around the sun, right? Because you have to remember we're looking at it at a circular motion around the sun being in the middle, and Earth being around it, we're observing that. And we have to remember that the orbit period is going to be 365 days. But we need to make that seconds. So that we convert it, do the conversion table. So from days, we have to go to hours, and then from hours to minutes, and then to seconds at the end. So it's 24, then it's going to be 60 minutes, and then 60 seconds. So after we do all that multiplication across, it'll be leaving us with 3.15 times 10 to the 7th seconds. And that's the first part, the bottom. Now we have to find the total distance. Now it does give us orbit radius in meters, the orbit radius in meters. However, we need to do 2 pi times the orbit radius to be able to find the amount of meters they went around in total. And after we see that they gave us it in orbit radius, which is going to be 1.50 times 10 to the 11, we will see that we have to also do 2 pi, remember, because of the unit circle. 2 pi will mean it'll be a full rotation, okay? And after we multiply 2 pi times 1.5 times 10 to the 11, it'll leave us with 9.42 times 10 to the 11 meters. So now we're left with meters per second. Now we have to just do the final thing, which is just V equals to D over T, which will just be 9.42 times 10 to the 11, all being over 3.15 times 10 to the 7th meter. And after we're left with that, the final number we're left with is 2.99 times 10 to the 4th meters per second. Now we're also able to solve the next problem, which is going to be B, and it's going to be looking at circular acceleration. So since we found the velocity, now we define circular acceleration. So the velocity we were left with last time was 2.99 times 10 to the 4th meters per second, right? But remember the equation for circular acceleration, it's V squared over R, and R being radius, and the radius they gave us was 1.50 times 10 to the 11 meters. Now we're dividing that, and now we're going to be left with, after we plug that in, is going to be 5.95 times 10 to the negative 3rd meters per second squared. Always remember that when we're dealing with acceleration, it has to be meters per second squared. So that's our final answer, 5.95 times 10 to the negative 3rd meters per second squared. Now for C, it's asking us to do the same thing we did for A and B. Now let's do it again. We have to find the time first for velocity, right? Now, to be able to find that, we have to convert 88 days towards all the way to seconds. And after we do the conversion of 88 days, right, from days to hours to minutes to seconds, which is going to be 24 hours from a day. It's going to be 60 minutes in 1 hour. And in 1 minute, there's 60 seconds. And after we convert it, we're going to be left with, in total, 7.60 times 10 to the 6 seconds. So we found our time. Now we have to also find our distance. And luckily for us, they give us orbit radius, which this time the distance is going to be 5.79 times 10 to the 10. We have to multiply that times 2 pi because that's a full radius, right? 2 pi. And then we're going to be left with after multiplying 5.79 times 10 to the 10 to the 10 times 2 pi will be 3.64 times 10 to the 11 meters. We're left with that now. Finally, we find our distance and distance over time, right? So we did our distance, 3.64 times 10 to the 11 meters, right? All over 7.60 times 10 to the 6, we found earlier, seconds, well, equals to 4.79 times 10 to the negative squared meters per second. Let me write this out. 4.79 times 10 to the 4 meters per second. Now we found A for C. Now to continue, we just square this on top and divide by the radius that we had earlier, which is 5.79 times 10 to the 10 power. And then after we do this equation for x circular acceleration, which is again AC equals to V squared over R, we will be left with 3.96 times 10 to the negative second meters per second squared. Remember, acceleration is always meters per second squared. Okay, guys, thank you.